Hi, everyone. There are plenty of seats down here if anyone wants to move downstairs. Okay, so welcome to today's seminar. As you well know, biomedical research has flourished in this country due in a very large part to the visionary establishment of both intramural and extramural research programs supported by the National Institutes of Health. Every day now we see and hear about newly acquired information from labs large and small, working on understanding all aspects of biology, much of which has direct impact on human health and well-being, and often from very unexpected ways. We are now in a period in which the biomedical research enterprise is being squeezed by at least two forces, one caused by our own success in attracting bright people to research careers, swelling the size of our enterprise, and one caused by recessionary and political forces that have resulted in reducing overall research dollars available to support these talented people. As a research scientist myself and now Dean of the Graduate School, I'm very happy to have with us here today Jon Lorsch to talk about his ideas for stabilizing the biomedical research enterprise. Jon is director of the National Institute of General Medical Sciences, which provides a major portion of funding for basic research in biological mechanisms in a wide variety of model systems, and also provides the majority of funding for the training of young scientists. Thus, his ideas and NIGMS policies have a huge ripple effect on all of science. Jon moved to NIH almost 2 years ago from Johns Hopkins University, where he was a professor in the biophysics and biophysical chemistry department. His research interests are in structural analysis of the eukaryotic translation machinery. He moved his research group to NIH, meaning he's still very much one of us, facing the challenges of maintaining a research program while also examining ways the NIH can help us all do this better. So please join me in welcoming Jon here today.
Thank you. Thank you, Lynn. So am I live here? You can hear me good. Thank you very much for the invitation to speak here. It's been a great visit so far. I got to talk about science yesterday, and I'm going to talk about science policy. I want to talk about some of the challenges that Lynn alluded to and some ideas we have for how we can meet those challenges. So one of the things I hope to convince you of during the course of the talk is that the future is actually not so grim, and that we really can, if we work together, improve the efficiency and the sustainability of the enterprise, and that the future actually is potentially quite bright. But again, it's going to take all of us working together to get there. Since I'm at a medical school, I'll tell you that. Whatever rules you have, I have 100 times more, so you don't have to worry. So I know many of you are familiar with NIGMS, but let me just give you a brief overview for those of you who aren't. The Institute has two overarching missions. The first is to promote fundamental research on living systems in order to lay the foundation for advances in disease diagnosis, treatment, and prevention. And the second mission, which is actually related closely to the first, is to enable the development of the best trained, most innovative, and productive biomedical research workforce possible. And I will just highlight this phrase here, lay the foundation, because that really is the fundamental mission that NIGMS is trying to achieve. So the research we support, the training we promote, are really laying the foundations on which the other 26 NIH institutes and centers promote their missions that are focused on specific diseases or specific organ systems, okay? Now they say you don't know an NIH institute until you know its budget, so let me tell you a little bit about our budget. The fiscal year 2015 budget was almost $2.37 billion. It's a little bit less than it was pre-sequester, but I think you'll all agree it's still a very significant amount of money. The way we disperse this money is that about 90% of it goes to support extramural research. So that's research conducted outside the walls of NIH at medical schools, universities, other research institutes across the country. close to 9 or 10% of the budget goes to our training, workforce development, diversity building mission. That's a little bit fuzzy because some of the things going on out here in the blue area in research are also related to workforce development and training. But what you can see from this is that we are an almost completely outward-facing institute. We have only one very small intramural program, which is a single postdoctoral research training program that funds postdoctoral fellows to work at NIH institutes and at the FDA, about 20 of them a year. So again, we are almost completely outward-facing, focusing on supporting research throughout the United States. Now, one thing I always like to say, a very important point, is that that $2.37 billion I mentioned to you is not monopoly money, okay? And this is something I take extremely seriously. That $2.37 billion budget we have is hard-earned taxpayer money. And so it's absolutely incumbent on us to make sure that that taxpayer money is being invested in the best possible way. So really our job is to ensure that the taxpayers' funds are invested in fundamental biomedical research in the most efficient and effective ways possible. That is, to get them the best returns, the most and the best science possible for their money. Okay, and that's something I think we all need to keep in our minds at all times, whether you are the person deciding how the money's invested or you're the recipients of that money. So this year, just a few months ago, we released our 5-year strategic plan, and I encourage you to go to our website. You don't have to write this whole thing down. You can just go to the NIGMS website and find this. But it lays out the general themes, goals, and strategies to accomplish these objectives and goals that the Institute intends to pursue over the next 5 years. One of the really key areas that we are focusing on as part of the strategic plan is reinvigorating our commitment to investigator-initiated research. And so you might say, well, why does NIGMS, which has historically been the home of fundamental investigator-initiated research, need to focus on reinvigorating its commitment to that? And the data behind that decision are shown here. This shows two different but related things. The blue bars, which are this axis over here, show the funds that NIGMS had committed to what you might call programmatic research, or specific investments in certain scientific areas in which the funds were set aside for those scientific areas. And to be less favorable, you might call it top-down research, in which NIH, in consultation with members of the research community, decide to put aside a certain amount of the budget and target it at a specific scientific area. And you can see that in the early 1990s over here, NIGMS had almost no money invested in this kind of programmatic top-down research. But between 1998 or thereabouts and 2003 or so, and actually for some years after that over here, you can see that that amount of money grew dramatically. And 1998 to 2003 corresponds to the doubling of the NIH budget. And so during that time, other uses for the amount of money that was continually coming into the system each year were found, and it was put into these kinds of targeted scientific initiatives. Now, the red line, which is the other axis, the right-hand axis over here, represents the percent of NIGMS's research portfolio that was dedicated to investigator-initiated research, sort of the reciprocal of these blue bars. And again, you can see that in the early 1990s, 99% of the Institute's portfolio was investigator-initiated research. But during the budget doubling and in the years following it, that percentage fell to the level it was in 2013 when I arrived at NIGMS of only 80%. So we went from 1% targeted research in our portfolio to 20% in the course of about a decade or so. Now we've concluded that since the budget doubling has been over for 15 years, it really is necessary at this point for us to shift this balance, to bring this red line back up, which is going to mean bringing these blue bars down. And that's something we've been focusing on both in the short term by making strategic decisions about how we are distributing our portfolio and what programs we are investing in and keeping running, and also in the long term as we think about how best to support science and the overall enterprise that we fund. Now, another way you can see the need for us to refocus our efforts on investigator-initiated research is to look at what we call the success rate for grants. Okay, so this plot shows three related things. On this axis over here are the number of research project grant, either applications in the blue line that were submitted to NIGMS. Research project grants are grants to generally individual or small teams of investigators, and what we're looking at here is investigator-initiated grants. The lion's share of RPGs are made up of R01s, which are the really bread and butter of the biomedical research enterprise. So again, the blue lines are the applications we received versus fiscal year. The red lines are the number of awards we made, so the number of grants we actually funded. And then the green line is what we call the success rate. This is the number of grants we funded divided by the total of number of applications each year. And so what you can see is that this green line started out at the end of the budget doubling nearly 40%. So nearly 40% of the applications we received in a year were being funded at the end of the budget doubling. This began to fall as the doubling receded to the point where in 2013 I arrived at NIGMS, it had fallen to a historic low of 20%. Okay, so it had almost been cut in half over that period of 10 years. We predicted, based on modeling and expected levels of grants or applications, that if we didn't make any changes to our portfolio, it was going to stay stagnant at 20%. And so a variety of changes in our portfolio we made. For instance, we reduced the number of funding opportunity announcements targeted specific scientific areas that we had out. We reduced the budgets of the large centers that we supported. Longer term, we've made decision to close some large initiatives that have been ongoing since the beginning of the budget doubling. And we did see some improvement this year. So rather than being stagnant at 20%, the success rate actually rose to 25%. Now, so that's positive news, to be sure, but just 2 points about it. One is it's critical as we move forward and continue to think about how we distribute our funds and manage our portfolio that we keep this success rate at least this high, if not increase it further, rather than let this be a spike of a single year followed by a return to these poor success rates. The other point I'll make, though, is I don't view this 25% success rate as good enough yet. I think we really need to continue to work on this to make sure that all the outstanding, or as many outstanding investigators as we can, who are struggling to get support, are able to conduct and continue their research. So those are two things that we'll be working on over the coming years. Now, that's just an introduction to some of the directions we're heading globally. And again, I encourage you to go look at our strategic plan to find out more details and more of our thinking about other areas. But people frequently ask me what I do all day long. And what I do all day long, in addition to going to a lot of meetings, is to think about very hard problems. And that's one of the appeals for me for this job, and one of the reasons I took it. I get to think about very important, very hard problems that if we could solve would really make a big positive impact on the research enterprise. And I won't go through all of these here, but these show some of the hard problems that I spend my time thinking about. They're things like the distribution of funding among investigators, the academic business model, how the scientific reward system feeds into both productive and unproductive parts of the enterprise, and issues related to the workforce and training and how many people we can support and are we adequately training them, for example. But what I realized as I thought about all these very hard problems is there was really one central problem that fed into all these other hard problems in different ways, okay? That influenced each of these hard problems in one way or another. And I determined, at least I thought, that if we couldn't solve that central hard problem, we were going to have a very hard time making a significant impact on these other hard problems. And that central hard problem, in my view, is how we support fundamental research. So as many of you know, the way we fund some fundamental research right now, largely through the R01 mechanism that I mentioned a minute ago, is a project-based funding model. So we ask researchers to decide what they're doing in their lab and to break that up, their project, or the research in their lab, up into specific projects, and then predict 4 or 5 years in advance exactly what they're going to be working on, right? Down to, here are the experiments I'm going to do over the next 4 or 5 years. Here are even the controls I think I'm going to do. And we let them break their research up as much as they are creative enough to do and apply for as many grants as they can write in terms of those projects they've now broken their research up into. Now, many people, myself included, think that this project-based funding system creates a number of inefficiencies in the enterprise. I'm not going to enumerate them all, but let me just tell you 2, in my view. The first is that this is not how science actually works, right? At least not the best science, right? If you can tell me exactly the experiments you're going to do over the next 4 years, I think they're probably not worth doing, okay? The best science is when you're following your nose and you find something interesting and you go off in that direction, and Enrique gets a new idea when he's in the shower, right? And he goes in the lab and makes his students change directions, right? That's when the big exciting stuff tends to happen, okay? And here we're constraining this. We're putting a constraint on how science actually works, and we're trying to fit a round peg into a square hole, or vice versa. Okay, so that's one problem. It doesn't reflect how the best science actually happens. The other problem is related to this hard problem, distribution of funding. As I mentioned, because we let people break their research up into as many different individual projects or grants as they are creative enough to subdivide, and get as many of those as they are able to convince study sections to give them, we've created a very skewed distribution of funding in the biomedical research enterprise. And let me just show you that for a second. Okay, so here what we've done is we've taken NIGMS grantees, so these are people that have at least one NIGMS grant, and we've counted the amount of NIH total direct costs each one has. Okay, so this isn't counting HHMI or anything else, this is just NIH funding. And then we've put them in bins based on the top part of that funding distribution. So this is the people who have up to 185,000 direct costs, up to 210, up to 320, et cetera. Okay? And so you can see what the distribution of our portfolio looks like. Now, the red line is the average number of NIH grants that each one of that the investigators in each of those bins has. So it goes from 1 all the way up to about 4.5. Okay? Now, if you analyze this in a slightly different way, what you find is that 5% of our grantees have 25% of the NIH funds that our grantees have, and 20% of them have a half. Okay, now, well, maybe that's weird NIGMS thing, but if you look at the entire NIH portfolio, it's exactly the same distribution. Okay, now that's a pretty skewed, long-tailed distribution. There was an article in the New York Times about a year ago talking about Medicare or reimbursement to doctors and physicians and how skewed it was and how big a problem this was going to become, and it was exactly the same skew. 5% get a quarter, 20% get a half. So if it's a problem there, I think I can make an argument that it's not the most efficient thing here. Now you say, well, okay, how much money? If you could recover some of that money, how much would it really put back in the system to help fund new investigators, to help keep really productive, excellent labs open? And if you just count the NIGMS direct costs that the people who have over $500,000 a year in NIH costs have, it's almost $400 million. Okay? So even if I could only recover 10% of that money, that would still be $40 million I could put back into our funding system. Okay, so I'm not talking about insignificant tweaking the edges. There really is significant improvements in the distribution that could be done to help young investigators, to help outstanding labs that are trying to get by on a single grant with 5 people in the lab. Now, counter-argument to this always is, well, the people that have that great amount of money, the 5%, they're the 5% because they're the best scientists and they're getting us the most for the money. They're making the big discoveries, they're publishing all the papers. Turns out, and I try to be as data-driven as I can in thinking about these things, it turns out that we have an increasing body of evidence that indicates that that is not true, at least not on average. Okay? So this was an analysis that was done in 2010 led by Jeremy Berg when he was director of NIGMS. And what it shows is in red the number of publications that arose from a grant during the grant period as a function of total annual NIH direct costs of the grantees. Okay, it's the average. Or the average impact factor of the journal in which that group published papers. Okay, and that's, both of these are flawed metrics. Someone could publish one paper that's much more important than someone else's 10 papers, but we're talking about averages here, so some of those things get buffered out, okay? What you see, these are the interquartile ranges, these bars. So you can see there's a big range, okay, that's true. But what's really striking to me about this curve is, okay, in the beginning part of the curve, it goes up very rapidly, as you'd expect. If you have no money, you're not doing much. But when you get to somewhere in the, say, $300,000 range, direct cost a year, when you go above that, you start to see, although it does increase productivity in terms of papers or in terms of the impact factor, the curve, the slope is very shallow, which is diminishing returns. Okay? You are not getting a unit increase in productivity or impact for a unit increase in funding levels. And so what was one of the things striking in these data was that once you got above about $700,000, $750,000, the actual net amount of productivity that was coming out of these things was actually decreasing, okay? Now, there are all kinds of reasons for this. To me, it comes down to bandwidth, okay? If you're focusing on, the stuff in your lab that's the core and what you're most excited about, you're going to be able to put more bandwidth into that. You're going to be able to mentor the students. You're going to come up with more ideas. As you subdivide that more and more, right, that's going to come down. The amount of ideas you have, the amount of time you have to put into it, the amount of time you have to mentor is going to decrease. And of course, the amount of time you have to spend trying to keep this enterprise funded is going to go up and up, which is time taken away from doing the actual research and mentoring and training, okay? Now, I do a simple back of the envelope calculation to make this point a little more clearly. My job, fundamentally, is to act as an investor of the taxpayers' money. Okay, I'm trying to optimize the returns in terms of, as I said, great science, the amount and the quality that we get for the amount of money that Congress decides to give us, whatever that is. And you can do, using these averages, a calculation. We say, okay, well, I have a choice, and I'm frequently faced with this choice in any given council round. One grant application came in. It's from an established PI. It got a great score. Let's say it got a 5 percentile. It's to get the established PI who now currently has 2 R01s and getting $400,000 in direct cost, a third R01. So they're going to go from $400,000 here to $600,000 here if we give them the grant. That's actually going to buy the taxpayer, on average, 1 more paper a year. Okay? Now that's an average. Okay, there are people who can really do better and beat the curve, but note that although there are people who can do better and beat the curve, there are, by the same token, people who do worse, who are getting funded, because that's what I'm showing you here. Okay, so that's one. The other is a new investigator. Okay, she's coming in for her first grant. It will be the only funding she had. She's going to go from essentially 0 to, say, 200,000. That's going to buy the taxpayers, on average, 5 papers. So the difference is 4 papers. Again, okay, I'm talking averages. There's all kinds of caveats here. But from an investment point of view, which one's the better bet? Okay, so that's kind of thinking that I'm trying to do. Another way of putting this is, what should our funding metric be? What should our measure of how we are funding science be? Currently, it's the number of grants we give. Okay, we say, how many grants do we give? What's the success rate of grant applications? The denominator being the applications, the numerator being the number of funded grants. But another way to think about this, of what we should be focusing on, is how many investigators are we supporting? Okay? Now that, when I first say it, often sounds trivial. Well, okay, you're shifting from grants to investigators, but it really is not trivial. It's a different focus, right? We're now trying to say what we, the NIH, wants to do is to maximize productivity and impact by focusing on how many investigators we're going to support at sustainable levels, okay? Rather than just throwing it open and saying, here's grants, go get them, and seeing how many people can scurry up 4 or 5 grants. Okay? It really is a different focus, and it's something that we, not just at NIGMS, but NIH-wide, are talking about. Should this be more of the thing that we're focusing on? Okay, so this kind of thinking has led us to start an experiment, which I want to tell you about now. It's called the Maximizing Investigators Research Award. I'll tell you the details in a second. The overall idea is to switch from a model in which we are funding projects and letting people get as many grants as they can for their projects to one in which we are supporting research programs, okay? Which would be a single grant to support the work in your lab, much more flexible, as I'll tell you, hopefully more sustainable, more secure. But once you have that grant, that's your NIGMS research funding. And we're not going to give you any more, at least for that 5-year period, okay? Now, what do we think the advantages of this mechanism are before I go through the details? And we think there are a number of potential advantages to this. The first is to increase the stability of funding. And I'll show you how we're going to do that. But we think that if we can increase the stability of funding, we will actually get better science from people because they will be willing to take on more ambitious projects and approach them more creatively. Flipping this around, I think many people agree that the instability of funding, the constant worry that you're going to fall off the funding cliff and be unfunded or have to lay off half your lab, makes people conservative. It makes people conservative in the science they propose and they attempt, and it makes study sections conservative in the science they fund. So that's one advantage. The second is to increase flexibility for investigators, to let them follow their noses, like I said, and change directions as new opportunities arise, as Enrique has new ideas in the shower, right? His lab's cringing right now, but we want to give them that flexibility. The classic example I like to give for why this is important is RNAi, okay? RNAi came from a failed control experiment, right? They did a control experiment. They saw they were doing antisense RNA. They put in the sense strand, and it worked just as well as the antisense strand, right? Now, could have ignored this, said, no, that's weird. Something strange is going on. Luckily, Andy Fire had the courage, and in fact the resources, because he was at the Carnegie Institute, and the freedom to follow this because he wasn't tied to specific aims. And he did, and hence RNAi was discovered, and we have this amazing new understanding of a central biological process and this amazing new technology. What I worry about, don't know the answer, but what I worry about is how many amazing discoveries have not been made because when the graduate student or the postdoc went to the PI and said, look at this weird result, this weird control, the PI said, that is kind of weird, but I've got to renew this grant in 18 months, so you got to get back to the specific aims because otherwise we're doomed, right? I don't know the answer, but I suspect more than a few great discoveries remain unmade because of that. As I mentioned, we also want to improve the distribution of funding. Okay? Now, we recognize there still needs to be a range, that some people really can efficiently use more money than the average. But we need to get to a situation that is optimized relative to where we are, that distribution I showed you. And one of the reasons is because we have no idea where the next big discovery is going to come from, just like that RNAi case. And we know from looking back at the history of science that discoveries come from all kinds of strange and unexpected places. Many of them are made at Yale, but many of them are not made at Yale, right? They can be made all over by all kinds of people studying all kinds of strange, unusual organisms, for example. Again, going to my investor analogy, if you're investing in the stock market and you only invest in the blue chip stocks, you're going to get, in general, a poorer return than if you have a distributed investment portfolio, because that maximizes the chances of the big occasional payoff and also mitigates your risks. Okay, so that's, I think, another core concept here. We also want to reduce the time investigators spend writing grant applications, right? Again, if you're trying to run a lab where you are trying to keep yourself funded either because you want 3 or 4 grants or just to keep that one, and you're writing multiple grants every year, that's time that you're not spending thinking about the day-to-day science and what's going to really be done next, as opposed to trying to predict in 4 years what you'll be doing. And it's time you're not mentoring or teaching your students, okay? So I think we really, again, could improve the quality and maybe the amount of science that came out of each unit lab if we would free people's time up by reducing the amount of grant writing they had to do. Related to that, we'd like to reduce the amount of grants that have to be reviewed, okay? People say to me wherever I go, peer review is broken, right? Peer review is the problem. You got to fix peer review, tweak it here, do this, change 12 pages is enough, 25. Peer review is not broken, okay? Peer review is just being asked to do something it cannot do, right? What peer review can do well is it can put things into bins. It can say, here's promising stuff. This looks really promising. Here's maybe, maybe promising, not quite as much. Here's the next tier. Maybe there's a fourth tier, all right? But the notion that we can rank grants, that I can say this grant on Drosophila eye development is ranked, is actually more predictively more likely to give a great result than this grant on C. elegans ovary development, which got a 5th percentile instead of a 1st percentile. Not only does it just intellectually not really work, we now have an increasing body of data that it's not true, okay? So the best thing we could do for peer review, the way we could fix, quote unquote, peer review, is to reduce the number of applications they're being asked to deal with, to let them do what they can do, which again is, make broader distinctions, and to increase the success rate, right? If the success rate is, let's just say 50%, that's a whole different world than if the success rate is 15%, right? Okay, so those are some of the things we hope to achieve. So the program, again, is MIRA, Maximizing Investigators' Research Awards. It's an experiment. It's hopefully an experiment that's going to be expanding. My goal would be to expand it rapidly if it begins to work. But let me tell you about what it's going to look like. It's going to be a single research grant per PI for NIGMS. It's going to use a new mechanism called an R35. They will, because it's going to be a single grant, on average be bigger than what we currently give, right? We want to give you enough money so you can do your research. We want to get you in the sweet spot, okay? So whatever that's going to be based on our budget, et cetera. And it's going to be a year longer than our current R01. So currently, 4 years is the average R01 at NIGMS. These are going to be 5 years. There's going to be a range of direct costs. As I said, some people are going to be able to convince the study sections that they really can use more than the median amount of money efficiently and get a unit increase in productivity at least. But the range is going to be from something small to $750,000. That's going to be the cap. Okay, and that again is based on the data I showed you, and is basically what we think that's the most money that NIGMS should be investing in anyone. Very few, in terms of research, very few people will get that much money, but that is going to be the limit. They're not going to be tied to specific aims. In fact, the grants don't have specific aims. Instead, the review is going to be based really on two things. One is retrospective. What did you do in the last period of time, whether that be 5 years or 10 years, okay? That's actually turns out to be one of the better predictors for at least established investigators of what they're going to do in the future. The other will be just lay out broadly what this area is you're working on, what you think the key questions are, and what you think the strategies are for approaching them, okay? You've got to have something, some vision that we assess, but you're not going to be tied to that. So if your postdoc finds something unusual in a control experiment in year 1.5, and that sends you off in a new direction, that is perfectly fine. In fact, you're not even going to tell the study section when you come in for renewal, and I should say these grants will be renewable, what the specific aims were originally. You're just going to tell them what you did, and again, overall, the questions and strategies you think you're going to follow. In terms of the stability, I mentioned that's a key aspect of this. We would like to improve the stability of the system so people aren't constantly bopping in and out of being funded and not being funded or coming from 2 grants to 1. 5 years versus 4 is one piece of that. That's maybe a minor thing, but an extra year, I think, from my point of view, is a positive. But maybe more importantly, we're going to be switching from the current binary outcome of peer review, where you're either funded or you're not, right, to one that's analog, So that sounds sort of retro. We're going from digital to analog. The idea, though, is that we'll be able to modulate funding levels based on peer review rather than necessarily terminating your grant. So say you come into peer review now and the study section says, oh, it was great work, it's pretty interesting stuff that you're talking about doing, but you're not the top 1 or 2 grants in my pile, so you got a 37 or something like that. Still a great score. Chances are now you're not getting funded at all. In this new model, what we're going to do is have the ability to say, okay, look, they're saying you weren't operating at the $400,000 direct cost level that you were at, but rather than just terminate your program, we're just going to ramp you down to something else, okay? So you keep going, you have to downsize a little bit, but you're not finished. You can keep your program moving. Okay, and I think that really will allow us a lot more flexibility and ability to keep the system stabilized than currently the on-off system that we have. Now, I was determined when we were coming up with this idea that I wanted to let new and early stage investigators into this program from the start. There was a lot of debate. Should we make them do R01s first and then let them come in? And one of the good things about my job is I could occasionally make an executive decision. So this is one I made. We are going to let new and early stage investigators straight into this system. But the pushback is always, well, you're basing this on track record in large part. That's going to disadvantage the young investigators. And of course it would if we were comparing them to the established investigators in the same panel. So what we're doing is we're going to have distinct separate panels for the established investigators and the young investigators, and different criteria, modified criteria for the young investigators. Okay? So in some ways that's even better than the current system because they're not going to be in the same study section and they're going to be judged in separate, hopefully improved ways. Now sometimes it's useful to say, to define something by what it's not. So I do want to make a couple things clear about what MIRA is not. So MIRA is not targeted specifically at high-risk, high-reward research. So this isn't the Pioneer program, Pioneer Award. For one thing, this is renewable. This is hopefully going to be a sustainable system. We do hope that the benefits I told you about will empower people to do more ambitious and more creative research. But we're not targeting it just at, you've got some crazy high-risk idea. We want this to be for all the great science that NIGMS traditionally funds. And by the same token, it's not targeted specifically at a perceived highly elite group. Okay, so we are not creating HHMI here, although we're using some of the, I think, beneficial aspects of that kind of person or program-based funding. Again, if this pilot experiment works, the idea would be to expand it to be able to fund the entire portfolio of NIGMS investigators, okay? All of whom are excellent, at least in my view. Now, what's the initial implementation plan going to be? And here's where the rub starts, because we can't, as much as I would love to, just say, everyone come in right now. The pool's open. And the reason is because A, we don't know if it's going to work. So, if there's some problem, we don't want to throw everything into one system and then find out there's a problem. Most importantly, we have to pilot the peer review system, because everyone agrees that this is going to rise or fall on how peer review works. And the peer review really has to be very different than the current R01 peer review. In many ways, it's got to be orthogonal to it. So we can't just let the CSR R01 study sections start reviewing these right next to R01s because they're going to review them like R01s. And we can't have that. Okay, so we really have to break the mold of peer review in many ways, start a separate system and try to make it work for what we're trying to accomplish here. And to do that, we need a moderate number of applications so we can test these procedures. And so we've already issued the first FOA. And the first FOA is for established PIs. And in order to get a small enough test group, we had to put some constraints in. So the constraints are that they either have 2 or more NIGMS R01s already, or one that's for over $400,000 in direct cost. So this immediately sounds like, oh, you're creating the elite group, okay? But remember that we are actually going to be asking these people to trade some amount of their direct costs on average for the benefits of the system and put that money back into the system to improve the number of labs we can support or the quality of support we give them. Okay, so that's a trade-off. They're going to lose a little bit of direct costs in exchange for all these benefits, extra year, et cetera. Now, the second one, which we are writing and is now going through the approval process, is for new investigators who are at an early stage of their careers. As I said, I was determined to let them in. And again, we're going to have separate review panels and criteria for them. If these start to look like they're successful, that is, if people apply for it, if no one goes to Tahiti instead of doing their research and continues to be productive, we are going to expand this as fast as we can. The goal would be to open it to everyone as soon as possible, but we really want to make sure we have the peer review process worked out as well as we can first. Okay, now I wanted to, since I talked about new investigators, just talk briefly about some new data we have concerning new investigators and early stage investigators, because that's an area I'm very concerned about, is getting these great scientists into the system, funding system, as soon as we can to get their labs off the ground and get them producing, and then keep it sustained, okay? Because if we lose a generation of scientists because we're not focusing on this, it's really going to be a detriment to the country. Now, one of the ways NIH has tried to support young investigators getting into the system is by mandating that every institute and center is supposed to keep the success rate for grants to new investigators at least as good as the success rates for new grants to established investigators. So new grants to established investigators. And these are NIGMS data. ESIs are early stage investigators, young investigators, and then the red bars are the experienced PIs. And you can see that over the last 5 years, NIGMS has been successful in keeping the success rate above the success rate for new grants for experienced PIs. But note that the success rate for new grants for experienced PIs is actually not very high, okay? And so one question I do have, and I'm wrestling with, is whether this is the right bar. As I'll show in just a second, the success rate for renewing a grant for an established PI is dramatically higher than this, okay? So we've set the bar pretty low, and we're saying it has to be at least as good as the hardest thing, that you can do. And I wonder if maybe we need something a little bit better than that. But another area we've been concerned about is the first renewal. So we're already giving new investigators, early stage investigators, some break. Maybe it's not enough of a break. But we give them some break, we get them into the system, and then we've been worried about what happens to them when they come up for their first renewal. Because anecdotally, this has been said to be really the stage at which they rise or fall, okay? And it's very hard to get that first renewal. So one of my program directors, Stefan Maas, has been taking a deep dive into the literature, into our data, looking at this. And so let me just show you what we have here. On the left over here is the percent of projects for all renewals of established investigators. So these are renewals of a new grant or renewals of a grant that's in its fifth renewal cycle, all for established investigators. In green are the grants that got funded, or what we call paid. In red are the grants that were submitted for renewal but not funded. And in blue are grants that never came in for renewal at all. There was no application, okay? In yellow, this yellow dot shows the success rate, because the success rate is just the total number of applications on the denominator and those that were funded in the numerator, not taking into account all the ones that never came in at all, okay? And so you can see the success rate overall for all renewals for established PIs is very high, okay? And it actually gets higher with each renewal cycle up to the third renewal cycle. So the first one is a little bit harder than the second, and the third is the easiest thereafter. Stefan then broke that down into renewals of new projects by established investigators. So he took out just the first renewals of new grants going to established investigators, and then he compared that to renewals of new projects from new investigators, that is their first renewal of their first grant. And what he found was that overall, the renewal rate, because this is just the percentage of projects that get renewed, was higher for new investigators than for established investigators renewing a new grant. So that seemed good, because that means that they're getting renewed more often than a new grant to an established investigator. But when we looked at it a little more closely, you realize that, in fact, if you compare the red and the green bars, the success rate, again, the yellow dot, is actually higher for renewing new grants for established investigators than renewing new grants for new investigators. It's not dramatically higher, but it's a little bit higher. And so that's consistent with the lore, that it's hard to get that first renewal. And that certainly concerns us. And so an area that we want to focus on is this first renewal. And how can we make sure that great new investigators are making it through this really critical stage of the first renewal. But another weird thing that you'll note in this, and I'll talk about more in a second, is that this blue bar for established investigators is much bigger than the blue bar for new investigators. So almost 40, or actually 45%, close to 50% of new projects funded for established investigators never come in for renewal. They just walk away from them for one reason or another. And that's something that we're interested in, and I'll discuss more in just a second. But another thing that Stefan did was to look at how the renewal rate compared to the initial score of that first application. So we're looking at new grants, either for established PIs or new PIs, okay? And he looked at the percentile score that that grant got when it was initially funded, and then compared that or binned that for the renewal rate when it came in for renewal, okay? And so on the left now are the new investigators, and on the right are the established. And if you follow the green bar for the established, you see that it goes down as the original grant's percentile score gets worse. That's what you'd expect, perhaps, a priori. You might think that you'd get more successful projects from the higher scoring applications, perhaps. But if you compare the new investigators bars, you'll know that the trend is not the same. In fact, the renewal rate for new investigators who were funded with grants that got at or above the 20th percentile, and these were generally grants that we were what we call reaching for, right? They were above where we generally would be funding, and because they were new investigators, we reached for them. Their renewal rate is actually higher than the renewal rate of the established investigators, and even about the same as the renewal rate of the new investigators who scored in the 0 to 9th percentile, right? So this really supports the idea that we should be, as we are doing, giving some benefit to new investigators in their first grant when we fund them, because it appears that the ones we reach for actually are doing quite well, both relative to new investigators who scored better and to established investigators. Okay, so that does support that. But again, I want to address this issue of the disparity between the fraction of grants that never come in for a renewal of a new grant for established and new investigators, and that trend you can see here quite clearly. Now, one possibility was that these grants that don't come in for a renewal don't come in for renewal on average because they are not as successful as the ones that do. And what this would then be telling us is that almost half of the new grants we give to established PIs, these are new grants, not renewals, weren't very successful. Again, that could be because of bandwidth. If you're giving a PI their third grant, they don't have as much time to devote to it. And so this is something I think we need to think about. And I will say that 60% of the established PIs in this pool who are getting new grants have at least one other grant from us. So Stefan broke each of these cohorts up that I just showed you, the new investigators, the established, according to whether they did not apply for renewal. So a T2 application is a renewal of that new grant. They applied for one, and then he further subdivided the ones who applied for a renewal according to those who didn't get funded and those who did get funded. And what he's looking at here, he's looked at it in about 16 different ways to measure productivity and impact. I'm just going to show you two, but he has, again, 16 probably different ways of looking at it. This is looking at the number of publications that came out of that grant period divided by dollars, so per $1 million for each of these cohorts. These are box plots. The black line is the median, and then the top is the 75th percentile, and the bottom is the 25th, and the full range is shown here. Okay, and what you see is, in fact, according to publications per unit dollars, the lowest cohort is the ones that didn't come in for renewal at all. It's lower than the ones that did come in for renewal, and that's kind of what you'd expect if this group was just not as successful, so they didn't come in for renewal. And the best overall look like the ones that were actually funded, which is somewhat heartening. Okay? Now, another way to look at that is citations per $1 million. So this is citations for the papers that came out of that grant period, again, divided by dollars. And he sees the same trend, which is that the lowest is the ones that never came in for renewal. The highest is the ones that did come in for renewal. Okay? So this supports the idea, again, that the reason, on average, that these people are not renewing their grants is because the projects were not as successful. And he's looked at other measures of impact using various Thomson Reuters things, using some internal NIH measures. We see the same thing over and over again. The other thing that's striking is that when you compare the new investigators' impact or productivity to the established investigators, it is always at least as good. In some cases, it's better. Okay, so this again supports the notion that it is a good investment to fund grants, first grants for new investigators, because they are doing at least as well by all these different metrics, if not better, than a new grant, yet another grant to an established PI. Now, the very last thing I want to say before I took some questions is I mentioned that the other mission of NIGMS is training, and there are lots of important things going on in the training arena, and I didn't want to change that by not saying anything about it. So let me just very quickly tell you some of the important areas we're thinking about in terms of workforce development and training. The first is developing the optimal workforce. And one of the key areas we're focusing on there is building diversity. And I mean diversity very broadly, going back to my investor analogy, from scientific questions to approaches to regions and to the backgrounds of the people doing the research. And the reason that's so important is because diversity improves performance. It's been showed in many different arenas that that's true. And so therefore, that's something we are focusing on through all these different dimensions. Ph.D. education, NIGMS funds almost half of the T32 training slots for graduate students and undergraduates that NIH as a whole gives. So we really are the 800-pound training gorilla. Some of the things we're really going to be pushing on over the next 5 years are to promote innovation and experimentation to improve outcomes of graduate education. So I really want to find ways to empower you, the people doing the training, to think about how to change it. Science has changed dramatically in the last 15 years, and I think it's maybe time for us to start exploring other models to improve how we're training scientists in response to this changing scientific landscape. To do that, though, we need to improve our ability to evaluate how training is working and to assess outcomes. And so that's something we're going to be focusing on both at NIH and in partnership with you. And also on career development. There's an increasing recognition that many people who get PhDs are going to go into all kinds of different diverse careers that utilize their training in important ways. And we want to see if we can improve their ability to do that and their value when they get to those diverse careers outside of the traditional academic researcher. Physician scientist education is also important NIH-wide and to NIGMS. We fund the MSTP program, the Medical Scientist Training Program that Yale has one of to fund MD PhD students. There was recently an advisory committee to the director report on physician scientist education, and one of the things they indicated they would like to see NIH and the community focus on is complementary models to the MST program. Okay? They said we should maintain strong support for MSTP, but we should also think about alternative complementary models that might be more efficient or more effective for certain groups of people. Overall, one of the key issues, as I'm sure you know, is retention in research. Right? There's this huge pull for physician scientists to go back into the clinics, especially when it's difficult to get research funding. How can we promote them to stay in research in the most efficient and effective way? And finally, last but certainly not least, postdoctoral training is something that I'm very interested in finding ways that we can improve and use more effectively. 70% of life sciences PhDs in the US right now go on to do postdocs, yet only 40% go on to actually run research groups, whether it be in industry or academia. Is that the right balance? So what is postdoctoral training for, and who should be doing it? If you're spending 5 years as a postdoc getting paid $45,000 a year, and then you're going to go on into a non-lab head career, was that the right choice, or was there a huge opportunity cost when you could have entered that career directly, been paid more money, started your career 5 years earlier? Improving postdoctoral training as a whole is something I'd also like to think about, right? Right now, most places, the postdocs are just working in the lab they're in, and that's pretty much it. Can we improve that experience for them? Can we add more value to them through some kind of structured training or mentoring in various ways? And so I think that's a very important and under-thought about group of researchers in the system. And I think we really owe it to the system and to them to focus more on what's happening in that space. So the last thing I'll say is just, I've told you about a lot of different things that we're working on. I've told you about a lot of different problems in the system. I hope I've convinced you that NIH is taking this seriously and is really willing to make significant changes and try major new things. But the fact is, we can make the biggest changes you can imagine, and theoretically the best. But if the rest of the system is not willing to make reciprocal changes, it won't make that much difference, okay? So this really is a shared responsibility, and I hope that you will join us, you'll communicate with us in figuring out how we as an enterprise can really right this boat and get it sailing the way it should be sailing again. So thank you very much, and I'm sorry it took so much time, but I'm happy to take questions. Up there. We have two up here. Okay. The red shirt.
All right, so that was incredibly thoughtful and thought-provoking. So thank you for that.
Thank you.
How would the R35 funding mechanism interface with project-based funding from other institutes or from private organizations?
Okay, I'll repeat the question since there are people on the campus. So the question is, how does the MIRA, the R35 mechanism, interface with funding from other institutes or private foundations? So we are just limiting the funding to, that's your NIGMS grant. We're not saying you can't have others, at least not at the moment, right? This was a discussion I had with other IC directors. We do, though, however, have the $750,000 direct cost trigger is what we call it. So if an investigator has $750,000 or more in total direct costs from any source, we and our council take a very close look at the budget of any grants we're going to give them and take into account that additional funding when making a funding decision and when deciding how much to give them. So that will factor in. And in fact, we will factor this in as we are making funding decisions as a whole, since this is now your funding from NIGMS. If we have one grant to deal with, it's a lot easier than if there's 3 others floating around out there from NIGMS as well. Moving forward, we'll have to see how it evolves. Does that answer your question?
Actually, I was also concerned about potentially double funding.
Yes. So that's something, again, so the question is double funding. So someone gets an NCI grant and their MIRA, and are they working on the same thing? So that's, again, something we're going to have to monitor very closely at the renewal stage and at the yearly progress report stages. Are these distinct enough? If someone has an NCI grant, is that really about cancer? Or is there something? And there's a gray area. And I think we have to, this is going to be a discussion moving forward.
Another one in the balcony?
So just to echo Mark's statement, that was very thought-provoking and very interesting and encouraging.
Thank you.
How are you going to deal in the budgets of these R35s with the fact that different investigators are being asked to raise very different amounts of their salary?
So the question is about salary support. So, and you see it here acutely. We have the dean of the medical school sitting here. At a medical school like I was at Hopkins or here, Faculty are frequently asked to raise 70 or even up to 100% of their salaries off of grants. That's the system that we've built up over the years. Whereas at an arts and sciences campus, it may be the inverse. You may only have to raise 30% your summer salary. One thing I didn't mention is that one of the requirements of MIRA is that you put 51% research effort on the grant, 51%. That's research effort, so it doesn't include clinical time, it doesn't include teaching time, it doesn't include administrative time. That helps us partly with this issue just because it means that we're not penalizing someone at an arts and sciences campus who is getting a hard salary by saying, you can't take as much effort, or et cetera. The overall question, though, what are we going to do about this salary support issue, is a harder one. It's one I've been discussing with various leaders in the community. I discussed it with the AAMC recently. It's something we have to wrestle with if we want to right that boat and make it sustainable. Pulling the plug immediately, I think, would be catastrophic, but moving towards some more sustainable mechanism, finding ways that NIH can support other things, whether it be research resources, core facilities, helping with startup packages in exchange for the institutions taking long-term commitments to salary supports. I think there are models that we can work with, and I really hope we can engage more with all of you and with the academic leaders to find those solutions, because we have to. There's two more up here.
Sorry, so what is the metric for success of the MIRA pilot going to be, and how soon could it potentially be implemented?
Right, so the question is, what's the metric of success for the MIRA pilot, and how soon can it be implemented? So I'll take the last first. We've started implementing it already. So we're taking applications now for that established investigator cohort. We're writing the one for the new investigator, and so hopefully that will be out in the early summer. And then we'll see how that goes. And so that gets to your first part of the question, which is success. There are lots of different metrics we are developing to measure success. So some of them are things like I showed you, like publications comparing the MIRA investigators to the people doing the old R01 system. I admit that's, publications is just one thing. It's flawed in various ways. But if you saw a big change in one group relative to the other, it would tell you something that you wanted to explore more. Citations being the same, et cetera. My guess is if we give people more freedom, an extra year, the average person gets a little bit more money, we're not going to see a decrease in those things in any substantial way. To me, more the success we have to look at immediately is, can we get more for the money we have? Can we support more investigators with this? Can we get a more diverse portfolio of research and investigators from this, as opposed to the opposite, right? So failure would be if, for some reason, we ended up with a very small cohort getting most of the money, and we'd actually shrunk our pool of investigators and reduced the diversity of our portfolio. So those are some of the kinds of things we're looking at. If it starts to work, we're going to expand it as fast as we can. Yeah, so the question is the MIRA mechanism being considered at other institutes? Yes, there's been a lot of interest from other institutes. I've spoken at almost 10 councils of other institutes now about this. Usually, in almost all of them, the response from the council has been very positive. NINDS right now is writing something similar. It's actually very much based on ours. It's going to have some tweaks and differences, I think, if it does come out. But it's the same idea. NCI has an Outstanding Investigator Award, which has some of similarities, but is actually, in some substantial ways, different.
So how much money are you putting into the established investigator and new investigator?
So how much money is going into it? So the established investigators is easy because they are already there. And so all we're doing at some level is taking one kind of research grant and changing it into another, okay? And so at worst, it'll be a zero sum, but we're actually going to shave, as I said, some money out of it and put it back into the system. So it's cost, at worst, neutral. The new investigators, what we have to do is figure out how many we want to fund. And part of what we're doing is looking historically, how many do we fund each year, and then try to decide, is that the right number to start out with or not? And that would be the maximum that could come in. Because for them, any new investigator could come into that who's doing work relevant to NIGMS. Again, though, if they get that, they're not going to get an R01. So it's not a set-aside in the same way that if I say I'm going to put a set-aside into transcription and give it to them, that would be a set-aside.
The cost of doing science keeps going up, especially with instrumentation. I work in cryo-EM where multi-million-dollar microscopes are needed to stay on the forefront.
Yep.
Does instrumentation figure somewhere in your pie chart, and how can that?
Absolutely. So the question about instrumentation and the cost of instrumentation keeps going up, and keeping the U.S. at the cutting edge requires continual investment and support. So I didn't have time to talk about this, but another effort that's going on right now at NIGMS is trying to optimize our support for both technology development and access to research resources, okay? And understand how to couple those two things and when to couple those two things. So that's something that will be coming out in the next year, I think. Two things I will note about that is, one, there's a lot of opportunity for improving the efficiency and creating economies of scale, right? So if we can provide, say, regional resources, or if we can help universities set up more efficient core facilities, I think researchers could get a lot more out of the same amount of money. Universities could save money. We could probably stretch our dollars more. So that needs to be thought about again in partnership. Cryo-EM, I've had a lot of discussions with. I'll just say we are absolutely committed, NIGMS and the discussions now going on NIH-wide, to finding the best way to provide access to these amazing new cryo-EM tools that are coming, and to promoting their continued development. It's a question of the most efficient way to do that. So we'll continue these discussions with the community.
So I hope you agree that we are lucky to have Jon at the helm of NIGMS.
Oh, thank you.
And thank you very much for...
Thank you all. Thanks. A lot of fun.